Welcome back. When I left off, I had just finished sheeting the wings. Here's what I've done since then. I cut and installed the elevon control horns. They use a pull-push rod setup with no linkage stopper to minimize points of failure. Next, I began to work on the fuselage. I started by laminating strips of 2-inch pink insulation foam, planing that material to thickness, and cutting it into sections. This was done with a hot wire which I built myself. It uses 30-gauge nichrome wire, 1-inch PVC, and has a maximum cut width of 14 inches. It's controlled by a servo tester and a Hobby King 45 amp ESC, which I'm overvolting quite considerably by running it on 4 cells. It's only ready for 2. I then laser cut a bunch of paper templates which were pinned to both sides of the foam sections and cut. In the future, I'd like to use wood sections to eliminate the horizontal striations that can be seen. The paper had a tendency to crinkle and take a bit too much of a cut. I installed a carbon fiber spar to keep things rigid, as well as 2 tabs similar to those in the wings to hold everything in place. Next was bodywork. I added spackle, sanded it down with 150 grit, and went in for my first coat of primer. I found that the primer had an annoying tendency to eat into the foam if it was applied too heavily, because the propellant would sort of pool on the surface and then it would just consume the foam. You could get away with light coats, but anything too heavy wouldn't work. I added more spackle, sanded it, and went in for another coat, after which there were more spots that need to be filled. This continued until there was a coating of spackle and primer over the entire fuselage, at which point it was hastily wet sanded with 400 grit and sprayed with a finishing coat. The result is good from afar, but far from good. The surface finish leaves a lot to be desired. At this point, I was well past the point of diminishing returns and elected to move on to the next task. I cut slots in the front fuselage for the canard. To install it, I cut along the top, making a hatch of sorts. I added a little arc for the canard's trailing edge to deflect into, glued the canard in, glued the hatch on, and filled the seams with spackle. This next part, installing the rear fuselage, was something I had been stressing over quite a lot. I took measurements of the width of the fuselage along its length and transferred those on the mid-fuselage, which was cut to allow the rear fuselage to start dropping in. I patched up the sheeting near the front of the root cord and progressively cut out bits of the fuselage that were preventing it from seating properly, until it finally did. It was then glued in place. More spackle was used to blend the two surfaces. Here's a quick test fit of both bits. I noticed the canard was a bit askew relative to the main wing, and attempted to correct this by torquing and re-gluing the rear fuselage. Got some of the misalignment out, but there's still probably a few degrees in there. It's not the end of the world. Here's everything assembled. Note the banana for scale. It looks quite a lot cleaner than the first version. I added some windows with electrical tape just for the maiden flight. There were still some small things to do, like cutting the main power wires to length and installing the XT90s on them, as well as figuring out the battery retention. Note that none of the battery's weight is carried on the nose section. This helps things structurally. With new batteries and finalized wiring, I performed one last static thrust test. For reference, the inlet ducting had some small plenums installed to further eliminate dead air behind the landing gear. I achieved 3.75 kilograms of static thrust, which is an improvement of 7% over previous, and that's now with the constricted thrust tubes. I also weighed the entire craft and validated the CG location by using the weight on each landing gear, as well as the traditional method of just balancing it. Before I started the taxi tests, Ben Harbour, I'll have a link to his channel in the description, he makes amazing stuff, pointed out that the nose wheel brakes would have a destabilizing effect on the craft as they act in front of the center of mass. It's the same reason why a tail-heavy airplane flies poorly, just in a different axis and to an extreme. With this in mind, I began taxi and braking tests. Right off the bat, I ran into a problem with the nose retract unit. It had a tendency to collapse under braking load as the slider went a bit too far and allowed the trunnion to be forced past it. I solved this by excavating the area above the nose gear because I hadn't designed it to be removable. Great job, me. And then I took it out, disassembled the retract, while, mind you, it was still on the plane because I couldn't get to the servo connector, and adding 2 layers of heat shrink and some CA glue over the little tab that contacts the limit switches. This modification stops the slider earlier and keeps it from going too far. Once I had fixed this, I figured I was home free, so I went out to taxi test it again. And then one of the mains had the same problem, where the trunnion slipped past the slider, and so I had to perform the same modification on those. And after that, the nose retract stopped working again, so I took that apart again, and I opened it up, and I found out one of the limit switches had died on me, and was sticking and stuff. And so I took off one of the limit switches, replaced the limit switch on component level, put it all back together, and it still didn't work. So, with all that out of the way, and having spent a day on trying to get the landing gear to work properly, I just decided to leave it down for now, and just deal with it, because I don't want to deal with it. There's brakes. And I'm going to release the brakes. So they work a little bit. There's brakes on. It's not as much as I was hoping, but it's certainly better than nothing. I do like the improved turn radius. It's quite a lot better. Got a lot of punch with those new batteries. So here's sort of the max control rates. Like, you know, it just feels more responsive, whereas the other ones were a bit sluggish. I think this will prove to be quite effective. Alright, we're going to retest the brakes here. I've shortened the linkage so there's a bit more pull on it. And I've also reapplied some hot glue to the braking area, so we'll see how this goes. Here's brakes on. That's better than it was before, certainly. Hopefully you'll be able to see when I apply my brakes, and hopefully the nose gear doesn't unintentionally retract, and hopefully the nose gear mount doesn't break off. That works pretty decent. I'm going to give that another shot. I had pretty good control there. It was pretty stable. I think they might have locked up. I'll have to check the tires for flat patches, but I'd say that's a hell of an improvement over what it was before. Here's your tires. So maybe a little bit of a flat patch on the one, but overall pretty good. That's all I've got for this build update. I'm in a bit of a time crunch as I've got to head back to college soon. The good news is that by the time you're watching this and seeing this build log, I'm ready to take the aircraft on its maiden flight. Video of the maiden flight will be taken and posted on this channel, as well as the forum post linked in the description as soon as possible. Leave any likes, dislikes, comments, suggestions down below, and consider subscribing if you'd like to see future updates. See you all next time.